Okay, so day 3, we'll look at the first derivative test. The first derivative test is used to determine relative extrema of a function. So absolute extrema, we studied that on day 1. Max, min, we said if it was continuous, it has to occur on the closed interval, and extrema can occur at critical numbers or endpoints. Alright, now what's the difference with relative extrema? If you think of the warm-up worksheet that we did on the first day, we briefly discussed relative extrema are turning points on the graph of the function. A relative maximum would be a hill on the graph of the function, and it's where the direction of the function switches from increasing to decreasing. A relative minimum is a valley on the graph of the function, and the direction switches from decreasing to increasing. So if we look at any continuous function, this would be a relative max, and down here would be a relative min. Hill, valley. If a function has a relative extrema at x is equal to c, then c is a critical number. So if a function has a turning point, a switch in direction, then c has to be a critical number. And where do critical numbers come from? Where the derivative is 0, or where the derivative does not exist. And what we'll look at with our examples is the converse of this theorem true. So if we have a critical number, then does it guarantee that a relative extrema will occur at that number? Okay, so the first derivative test. We begin the first derivative test exactly like we did in class on day 2, when we determined where a function was increasing or decreasing. What we do then, after we've completed the number line, instead of just determining that where the derivative is positive, the function will increase, now a sign change tells us what type of extrema will occur. So if the derivative switches sign from positive to negative, then a relative maximum will occur. Because if we think about what the function's doing, the function is changing from increasing to decreasing. So if at a critical value the derivative switches from negative to positive, a relative minimum would occur, because the function would be changing from decreasing to increasing at that point. Then if you look at the third critical value, there's no sign change, so the function would be strictly increasing, and therefore there wouldn't be a turning point. So a turning point has to have a sign change in the derivative. Alright, so use the first derivative test to determine the relative extrema. So if we use our notes from yesterday, you can verify that for this function, this is the number line we set up. We tested points and found that the derivative was negative and then switched to positive. So we knew that the function at negative 7/2 switched from decreasing to increasing. So now by our first derivative test, a relative min occurs at x is equal to negative 7, using one simple statement to justify, because the derivative switches from negative to positive. What is the relative min though? We would plug the critical number back into the original function. So f of negative 7/2, 49 over 4 minus 49 over 2 plus 10. So we get 49 minus 98 plus 40 all over 4. So this would give us negative 49 plus 4, so negative 9/4 would be the relative min. And it's important that we can find those values, because when we go to graph the function, they're very important points on the graph. Okay, the second example that we did in class, we found our critical numbers to be pi over 3 and 5 pi over 3. Trig is always given on an interval because trig functions are periodic, so we only look at one particular piece of the function. Now, as you're doing this the first couple times, if it's helpful to continue to write a number line for the function, function is decreasing, switches to increasing, and then is decreasing again. And again, this is what we talked about yesterday. We just talked about intervals of increasing and decreasing. So now, a relative minimum occurs at pi over 3, since the derivative switches from negative to positive. And then we would say a relative max occurs at 5 pi over 3, since the derivative switches from positive to negative. It's tedious, but you do have to justify. On the AP test, you can use a number line to organize your answer, but you have to actually use words to justify it. So where does a relative min occur? We plug pi over 3 back into the function. I guess RM doesn't help at all. And then our max, when we plug 5 pi over 3 into the function, 5 pi over 3 is in the fourth quadrant, so the sign is negative there. So the only thing that changes would be pi over 3 plus root 3, because the sign of 5 pi over 3 would be negative root 3 over 2. Let's just separate those. Okay, so in class tomorrow we'll discuss, can a relative extrema ever occur at an endpoint? So please answer the question and prepare a justification for it. Alright. Using this example from yesterday, on our number line we had our function decreased, increased, and then increased after 0 again. Looking at the sign change, f of x has a relative max at negative 3/4, since f prime of x switches from negative to positive. Now if you notice at 0, the derivative never switches, so the function remains increasing to the left and right of 0. So therefore, there's no relative extrema at 0, only when a sign change occurs on the derivative. So we have 81 over 256 minus 27 over 64. And we can find that answer together tomorrow. Alright, we have the derivative here. We found the critical numbers to be -1, 0, and 1. Oops, not decreasing. Increasing and then decreasing. And just like the previous example, notice there's only a sign change in the derivative at 0. So the only relative extrema that occurs, which is a relative max, at 0. This is a simple substitution. So -1. If we go back to the original, the domain of this function is that x can't be positive or -1. So when we found the derivative, they gave us critical numbers, but we couldn't have a turning point at 1 or -1 because if we attempted to plug it back into the original, the function doesn't exist there. Now we talked about this yesterday. The domain of this function is all positive reals. So when we were using test points, we couldn't test a value less than 0 into the derivative anyway. So one sign change, f of x has a relative min. At t is equal to 36, I guess that would be t. Since f prime of t switches from negative to positive, and where is the relative min? F of 36 would be 36 times 36 minus 8 times 6. -6 times -12. What would that be? 360 plus 72, -432. So if we think about graphing this would be a nightmare because look at how small that value is. So we won't be graphing every single function. Okay, so for class tomorrow, answer the question, will a relative extrema ever occur at an endpoint? And go back through the examples and tell me, is the converse of this very important theorem true or false? If a critical number of a function exists, then the function has to have a relative extrema at that point.